we have a really amazing session that is going to, also help you learn more about these things, which is called Sentiment Analysis of Resource Scarce Languages. And it is going to be presented by Rama Soumya. So welcome, Rama. Thanks a lot for joining us. Would you like to tell the
Hi.
students a little bit more about yourself?
Hi, so I'm Soumya. I'm a pre-final year undergrad from India, and I've been an MLSA for almost a year and a half right now. So I'm really excited for this session.
Yeah, likewise. So yeah, let's get started. I'm super excited about this sentiment analysis, trying to figure out what the texts actually mean
Yeah,
because
it's about resource scarce
yeah.
languages, so we wouldn't be dealing with English, so it's a
Mm,
bit more complicated too.
nice. Super looking forward to it. So the stage is yours. Take it away.
Thank you.
Good luck.
Can you see my screen?
Yep. It's visible.
Okay, that's good. So, hi everyone, I'm Ramaswamy Narparaju, and I'm going to be talking about sentiment analysis of resource-based languages. So, let's come to the point, and in this session, I'm going to be giving an introduction to sentiment analysis. I will be talking about how sentiment analysis is done for English, and then we would be going through how Azure Text Analytics API works, just as Sharif and his partner was talking about in the previous session. And then I'll be talking about how these methods are different from the methods that we use in sentiment analysis for resource-based languages. So let's get started. So what is sentiment analysis for a starters? Well, sentiment analysis is a natural language processing technique which, when we given a paragraph or a text, we determine the sentiment of that text or paragraph. It could be also be called as opinion mining because we are mining the opinion. So when we give a text or a paragraph to a sentiment analysis or a sentiment analysis code, what happens is we check whether the sentence or the text is in a negative or neutral or positive sentiment or emotion. Let's take, for example, totally dissatisfied with the service, worst customer care ever. When we look at the sentence, we immediately know that it's a negative sentence. But how did we know that? We got the adjective there. Totally dissatisfied, which is a negative emotion, and then worst is a negative emotion. So we conclude that this sentence is negative. And then when we move on to neutral, we find out that good job, I will expect a lot more in the future. So when we see this sentence, we see the word good, but we also see the word expect. So it wouldn't be a positive sense, or it definitely wouldn't be a negative sense. So it would come under a neutral sense. So when we look at this sentence, we would conclude it as a neutral sentence. And when we go to positive, it would become brilliant effort, guys. Loved your work. When we see the sentence, we see brilliant and love. Two adjectives which are completely positive in sense, which completely leads the sentence to become positive in nature. So when we write code to detect the sentiment in a sentence or a text, how do we do it? So I'm going to be showing you how sentiment analysis is generally done and how it is implemented by us in English. So first, we acquire the required input data. Obviously, we need some kind of data that we need to run the sentiment analysis code on. And then you tokenize the data. I would be going through each and every code of this in the later slide. So we will look each and everything into detail later. And then after tokenizing the data, we would normalize the data and then remove the noise from the data, determine the word density and preparing the data for the model and building and testing the model. So each of these code and each of these steps in the sentiment analysis process is completely required, and we use each step in this code is some kind of breaking down the sentence and breaking down the emotions in the sentence and looking out for what kind of words, adjectives, or verbs that are in the sentence that would give us a lead on to what the sentiment of the sentence is. So let's get into the code. When we see this code, we're importing NumPy, Pandas, and then we're importing NLTK, and then we're importing Matplotlib, and we're importing Stopwords, WordCloud. So what are these imported files in this code? So we all know NumPy and Pandas are general machine learning Python libraries that we always import. And then NLTK is also a general NLP library in Python that we usually import. Stopword is a built-in NLP Python library which we use. The stopwords library general consists of words which we do not need in a sentence. So if we take the sentence like the dog is up a tree, I don't need the dog is up. I don't need any of these words in that sentence. They give me what the sentence is coming at, but they do not give me what the sentence sentiment is. I cannot get any sentiments from this is an A, obviously. What can I get from that? So we compare these words to the stop words and we remove these words so that we do not have to deal with these words to find out the sentiment. And then word cloud and stop words, this is also something that I will be discussing in the next slides. Here. Well, we're obviously gonna have to read the data. So we get a .csv file or whatever file you have your data set in, which we usually get the data for what we're testing for the sentiment analysis. So when we get this data, we divide the data into train and test. Obviously, for a machine learning model that we're building, we divide the data set into training data and test data. On the training data, we train our machine learning model on, and then we test the machine learning model with the test data. So that's why we are gonna split the data and then we're gonna train the model. So in the next few steps, what we're going to do is tokenizing the data. So what is this tokenizing? Tokenizing is a very popular NLP technique that we use. So when we are generally using a sentence, and then if let's consider this sentence again. Dog is up the tree. The dog, we just need dog. We don't need is, up we need a, we don't need that, and tree. So the dog, up, and tree are considered as tokens, and we split these words. So if we look into this code a bit more, we would see that we're training the data on the sentiment if it's positive, and then we're checking the text, and then after we're checking each and every word in the data if it is in the stop words or not, and if it is in the stop words, we remove the data, and then we are clustering the data. If you know machine learning algorithms, we usually cluster the data to find if we use k-means method in machine learning, what we do is we take the means if we have some kind of data scattered around a plot, and then we need to classify this data. What we do is we take the means of all the data one by one, and then we take the means of some group of data, and then we check each of the data until it goes on in iterations, and we keep checking the means of the data until we get different clusters of data in which all the means are almost the same with negligible amount of difference in the mean after each iteration. This is the k-means clustering. So we apply this here, and when we find out what kind of positive data, positive words, negative words, and neutral words are there in the data, we make it into clusters, and then we show it in our plot. So what happens is basically you have a set of words with you which are tokens, and then what you're doing right now is you check each word if it's positive, negative, or neutral, and then you keep checking the words. If it is positive, you keep all the positive words in a cluster, and if it's negative, you keep all the negative words in a cluster, and if it's neutral, put them in a cluster. And then you keep checking these words if they're positive, negative, or neutral until after you check each and every single word about a number of iterations, you get to the point where you get no change. The positive words do not go to the negative, and the negative words do not switch to neutral. The clusters remain the same almost after each iteration. So we stop the iterations and we get the clusters. So we show that in a plot, and then we normalize the data. So what we're doing here is we are checking the words, and then we are checking if it's the filtered word or a clean word. So we need to check the words again. So if it's in the stop words, or again, this is for English. So we have a lot of stop words that we could use, and there's a lot of data that we need to go through. So again, we have to check that. And then we remove the noise from the data. So what is this noise? Basically, the noise is same as I was telling before. The is, up, is, A, and B. So this code is generally used on Twitter tweets. So I was generally, if you have some tweets on Twitter and you are trying to run sentiment analysis on those tweets, what would happen is these tweets, um, these tweets would for all the tweets in the for all the tweets in the word, all the tweets in the data set, you would check each and every word for what sentiment in the data is. So if there's a tweet such that my dog ate something today. So we would check the sentiment of the analysis for that data for every single word, and then we check the distribution and the frequency of what kind of words did we get in the entire paragraph. Since this is just a line sentence that I gave as an example, you have to check the entire paragraph. You would get more types of frequency and different types of features, word features in it. So we extract those features. So what are these features? Again, the features of a sentence would be the main noun, verb, and adjective, removing the prepositions and the unnecessary words that we don't need. We don't get any kind of benefit from having in the sentence that we could actually get the sentiment of the sentence from. So when we go to this point, we get to the point where we see that we classify and we determine the word density. So basically, when you have the paragraph, so you're checking what kind of words are positive, what kinds of words are negative, and then you compare these words to the before words that you got, and on the previous sentiment analysis data that previous people have done and had in a data set. So if there is a data set where a person said bad is a negative sense, you have bad in your word in your sentence, you would obviously put the bad as a negative sense. So this is what we do right now. We compare what we have in our sentence to previous data sets and previous data that we had, and then we would check if the words are similar. So if it's bad or some kind of negative sense word, you would classify these words and features, and then you would put it out. So this is what we do in a general sentiment analysis for English. So this isn't something. If you see in this previous code, you would see that we had a lot of data that we already had that we could use for further use. We had the stop words. First of all, we had stop words that we knew in English that we do not need these in a word, so we immediately remove that. So again, what we have is we have previous data that we could compare to. So what do we do if we don't have these kind of data with us? So going further, I'm going to talk about how Azure Text Analytics API works on sentiment analysis. This is how we do it with code and how we generally do sentiment analysis when you want to do it from scratch. So how does the Azure Text Analytics API? So Azure Text Analytics API, it offers 5 services. So that are sentiment analysis, key phrase extraction, language detection, named entity recognition, and deployment on the premises using Docker container. So sentiment analysis, as we already know, sentiment analysis tells us what the emotion of the text is. And as Sharif already told us, he gave us a live demo on how sentiment analysis API works on Azure. So it generally gives us the percentage of negative, positive, and neutral. The key phrase extraction that happens in Azure Text Analytics API is it extracts the important words from the sentence. So again, in the sentence that I gave, the dog climbed up a tree or the dog went up a tree. That's not grammatically correct. So the cat went up a tree. So what would happen is the key phrase extraction, and these would be the dog climbed and up a tree. So what will happen was the other words in the sentence are dropped because we do not need these words to tell what the sentiment of that sentence is. And the language detection, Azure actually detects over 150 languages. So all these languages, if you give a language and then it would just detect the language and it would give out like you gave me this language, so this is the sentiment of the whatever sentence you gave in that language. And named entity recognition, what Azure does in the Azure Text Analytics API. So if you have a noun or some kind of word in your text that is a named entity that is already known to the web or something like that, like it's a known thing, like a pre-processed thing, it recognizes that and gives it out too. So that is one of the main features in Azure that I really never saw in sentiment analysis. So even if we write it from scratch, we usually don't include that in our code. So that is something that Azure offers. So that's something that stands out, that makes Azure Text Analytics stand out from the others. And then deploy on premises using Docker contains. This is something related to how we deploy the Azure Text Analytics API on Azure, rather than on focusing on sentiment analysis. So basically, sentiment analysis, it finds out what the customers think of your brand. So how we use the text analytics API would be, we could consider like analyzing the raw data that we get from customer services, like how Sharif gave us this example, right? So they gave us this example that I like the hotel, but I did not like the customer service. So sentiment analysis, it analyzes that data and gives out whether it's positive or negative. So generally, sentiment analysis is actually used in these applications where people or customers from all over the world, they go to this restaurant or some kind of business and they leave reviews behind. Going through all the reviews manually and also classifying these reviews on how many are negative, how many are positive is manually. It takes a lot of time and it's completely not efficient when we could just use technology for it. So usually sentiment analysis is an application is used there for businesses that want to check if their responses are positive in nature, negative in nature, or neutral, so that they could improve their customer service. So and another one is key phase detection. I already talked about this. It automatically extracts the key phases to quickly identify the main points. It literally just takes out the main points of the sentence and leaves out the others. So, which means that they're stop words and they're analyzing the sentence through much better process than the usual code that we use. So, it would have bigger layer, like more code for it, obviously. And language detection, Azure detects about up to 120 languages where the language input is written in and reported as single language code for every document submitted on the request. Usually, when we use sentiment analysis, Sharif team showed us how sentiment analysis API, the text analytics API, is used in Power App. So usually, when you deploy it on Azure, you have to use the to post and to get methods on Azure Cloud when you're deploying on it. So put when you literally give a text of a different language, so Azure Cognitive Services, Azure Sentiment Analysis supports Hindi. I don't think it supports Telugu, but it supports Hindi. So when you give a text in Hindi, it would automatically detect the language as this is Hindi, and it would give what kind of sentence is it's neutral or negative or positive on based on the previous Hindi data that it had and also the previous stop words and everything that it had, and it would give us the output of whether the sentence, obviously the sentiment of the sentence. So there are like 120 languages on Azure and it's still building right now. So we saw how sentiment analysis of Azure Text Analytics API works and how general sentiment analysis works. So the main problem arises is what do we do if we don't have these resources? So we don't have stop words. I mean, it's not like we don't completely have the stop words. It's just that the resources are scarce. So if we have just a small amount of data on what we need to do sentiment analysis on, how could we do this sentiment analysis when we do not have enough resources? Comes into the bigger picture, it becomes a problem. And well, we obviously have a solution for that, or we're going to find a solution for that. So my opinion on sentiment analysis for resource scarce languages, there are three techniques that we use. There are a lot more techniques that we could use. So I will be only discussing three of them, which is the machine learning technique, the lexicon-based technique, classification technique, and the label propagation. So in the machine learning technique, we usually use this for supervised methods. Kunal was explaining how about supervised and unsupervised models in machine learning in his session. So usually this machine learning technique for sentiment analysis would be used on supervised methods, and we would be using pre-existing collected opinion corpus. So what we would be doing is we would be using the small data that we have, the scarce data that we have, and we would be using text mining techniques. So using these text mining techniques and linguistic and statistic more methods and tools, we would be combining them, and then we would be we would generally be generally, it would mainly be on text mining techniques rather than on how we did it for English. So we would be going through like building a model for these for the data on the data that we have, and then when we test the model, we get the sentiment analysis of this model, right? So what would happen is we get what the words mean and what the singular words mean. So since we have the data and since we got the result what each word meant, so we have some more data for the next sentiment analysis that we're going to do. So we keep increasing the amount of data that we have, and in the end it becomes a resource language that has resource instead of a resource scarce languages. So that would be the machine learning technique. Next, when we come to lexicon-based classification technique, lexicon-based classification technique would be it basically what it does, it compares the adjectives. So lexicon in a lexicon based classification technique, we take the language. So the language would have some kind of words, right? The adjectives in the language and the verbs in the language, the nouns in the language. So we would obviously be having the words if it's a negative sense or a positive sense, at least for some of the words. So when we classify them based on the adjectives of the word by comparing the adjectives and not by building a model, a machine learning model. So that would be the lexicon based classification technique. And the last one would be label propagation. Label propagation is more of an advanced technique. It isn't comparatively to machine learning technique and lexicon based technique. It would be comparatively advanced. So what we usually do in label propagation is we first extract the sentiment features and then we build a similarity graph. So if you have ever studied about NLP and the basics, the startings of NLP, what we do in NLP is we start off by building a graph from each sentence that we got. So when we build a graph, a tree, actually a tree, we build it, not a graph, we build a tree from it. And then we start building a tree upwards, or it could be built downwards. There are top-down approach and bottom-up approach. So similar to that tree, when this is the complete starting of NLP, some 20 years back they used to do that. So if we follow that approach and build a similarity graph, and then on this graph we would be learning on this similarity graph. So how do we do this learning? Again, it would we have algorithm for label propagation, and it is somewhat similar to clustering that I had explained before. Basically, what we would do is each graph, we take a graph filled with the sentences that we already have, and then we run this algorithm on it, which it's not completely clustering. It's different from clustering because in clustering we have different algorithms because K means clustering and different types of clustering. So it isn't completely clustering. It is relatively almost the same concept of clustering. So that's what label propagation does. And whatever technique that we use, machine learning technique, lexicon based classification technique, or label propagation technique, at the end we have to evaluate what the model is and how do we evaluate the precision of the model basically. So usually for this we use support vector machines. Support vector machines are they're actually a famous supervised learning algorithm, and we could use naive Bayes or maximum entropy. So this is what we could do for sentiment analysis for resource-based languages. There are a lot more methods that we could follow for this because this isn't the only way that we could go for a resource-based languages. If we take, for example, language like Telugu or any kind of Indian language like Tamil, Kannada, we have the basis of the language. We know what is negative, positive, and we know what's gonna be a negative sentence, what's gonna be a positive sentence. The only problem that we have is that we don't have enough resources that we actually perform sentiment analysis on. So we don't have enough data to depend on that. So as we start running sentiment analysis on a larger amount of data, we get more data, and then this progresses to becoming at a resource-based languages. So that was what we could do for sentiment analysis of resource-based languages. If you think you have a incredible idea that we could do for resource-based languages without using these techniques, do let me know. And yeah, I'm Saminar Praju. I'm an third year undergrad. And yeah, any questions?
First of all, thanks a lot for the presentation. That was amazing. The reason it was amazing was you also showed the code base. You also did a recap of whatever we had covered so far in the conference. That was amazing. Thanks a lot for that. We do have one question over here that I see, which is how do you deal with reversed meaning negative words used in a positive sense? This usually occurs when we're using slang words, right? Bad
Like
can mean
sarcasm?
good. Yeah, some slang words. So in like let's say the slang, the adjective bad can means good. So would you first have to identify your text input as slang, or could this be factored into the data set?
Well, I would say that would have like two approaches, because one of the approach would be you could do it from a graph side. So when you take it from a tree side, actually, sorry, I'm getting confused with that. So when you're taking the sentence in a tree form and then you're trying to take the adjectives, verbs, and consider a top like bottom up graph. So what would happen is, so what? Uh, just a moment, I set my timer.
That's
So,
okay. We have time. Three minutes something.
okay. So what would happen is when we build a bottom up graph, so you have the sentence at the bottom, right? So you have to put up what kind of verbs and adjectives that you have. So when you're giving a sarcastic sentence, you would see that the words like come after each other, and then the prepositions, the stop words wouldn't work at that time to be technically fair. Yeah. So
That's
yeah,
true.
it would come out to be, I think, negative in sense, because most sarcasm aren't very positive.
Yeah. You might have heard, you all might have heard, like, first of all, that was a great explanation. But you might have heard about like confusion matrices. So there
Yeah.
you, from that, you have true positive, true negative, false positive, false negative. There's this thing called you figure out the accuracy, precision, recall. And this is something you can take a look into later on. And you can also join the cafe and ask your questions over there. There's this thing called F measure, which is basically like tells us the performance of the NLTK models. So we have one more question for you, which is, so we talked about like resource scarce languages, right? So can you maybe tell us a bit more about what are some practical examples of using sentiment analysis for these languages?
So how about we take Telugu, which is my mother tongue actually. So if we take the Telugu word, so if we have a completely Telugu based, like a Telugu based farmers or some kind of rural application, and then we need to find what kind of responses that we're getting from the farmers in that application. We cannot do this based on English, right? So we're gonna have to go for Telugu based sentiment analysis algorithm. So that would be a major thing that we need, because there are a lot of farmers throughout India, throughout the world, and not all of them speak English, not all of them speak major languages, which are sentiment analysis algorithms are available on. So it would be basically a bridge for those people to technology.
Yeah, most definitely. And I totally agree because inclusivity is key. Even when we're talking
Yeah.
about like initially in technologies, most of these, let's say voice assistants as well. So they were like just in English. But now I'm seeing like they're like in Hindi, in English, in like, all these different languages. In India, particularly, let's say we have so many other languages. In other
15,
countries also there.
21
Yeah.
languages, which we
Yeah,
cannot cover too.
exactly. So yeah, it's like it's a work in progress. I see like
Yeah.
many orgs are like on their way for that. But this was amazing. This was great. Thanks a lot for sharing. And for those of you who have another questions, Rama will be also like there in the cafe, so you can ask your questions over there. And yeah, thanks a lot for joining us. I like
Thank
to
you. Thank you for
pass on
giving me
the
this opportunity.
yeah yeah,
Thank you.
and it was really great. And yeah, really learned a lot. Thanks a lot for sharing. Cool.
Thanks for your great session.
Thank you.
Alrighty, now I would like to pass the stage to Zal. We have our next session, which is on, well, this is one of the most important and requested sessions, which is Introduction to ML. Even before this session, we had questions related to this session. So really looking forward to this one. Yeah, Zal, the stage is yours. Take it away.